The visitor no one saw coming. Out beyond the known planets, past the whispering winds of Neptune, in the silent darkness between the stars, something was moving. Something no one expected. No one had seen it arrive. No telescope had captured its entrance. No early warning had been given. It simply appeared. A thin sliver against the void, racing faster than anything bound to our sun, spinning, tumbling, an interstellar wanderer from realms unknown. It defied everything we thought we knew about space, about physics, about the quiet order of the cosmos. By the time we spotted it, it was already leaving, fading into the distance, slipping away into the eternal night. It would be the first of its kind ever seen by human eyes, and it would leave behind one of the greatest mysteries in the history of astronomy. This is the story of Oumuamua, the messenger from another star, the question that refused to be answered, and the spark that set imaginations ablaze across the world. A stranger from the stars. For centuries, we gazed up at the night sky, imagining visitors from distant worlds. But we never thought we would find one. Not like this. On a quiet October night in 2017, astronomers at the Galaxive Observatory in Hawaii noticed a strange point of light sweeping across the sky. At first, it looked like a comet, then like an asteroid. But the more they studied it, the stranger it became. Its path was wrong. Its speed was wrong. It wasn't orbiting the sun like the other wanderers we knew. It was cutting through the solar system on a hyperbolic trajectory, moving too fast ever to be caught. It hadn't been born here. It was just passing through. They named it Oumuamua, a word from the Hawaiian language meaning scout or messenger from afar arriving first. It was a fitting name for an object that seemed less like a rock and more like a whisper from the deep cosmos, a fragment of some other place, some other time, racing through our backyard before disappearing forever. But as telescopes turned toward this tiny visitor, trying desperately to catch a glimpse before it vanished, new questions emerged. Questions that no easy answers could satisfy. What was it? Where had it come from? And why, against all odds, did it seem to move as if propelled by an invisible hand? In the cold spaces between the stars, something had stirred. And now, it had found its way to us. The discovery that shook astronomy. It began like so many discoveries do, quietly, almost by accident. On October 19, 2017, a system called Pan-STARRS, designed to scan the skies for near-Earth objects, caught something strange. It was small, dimensions moving fast. At first glance, it looked like a comet, the kind we occasionally find wandering the solar system. But there was a problem. There was no coma, no dusty halo, no sparkling tail. It was simply a point of light, moving too swiftly across the stars. Scientists quickly realized that this object wasn't just unusual, it was unprecedented. Its orbit wasn't elliptical, like everything else that danced around the sun. It was hyperbolic. A sharp, open curve that meant it wasn't bound by our star's gravity. Oumuamua wasn't visiting from the outskirts of our solar system. It was visiting from another star entirely. This was a once-in-a-lifetime event, the first time humanity had ever detected an interstellar object passing through the solar system. For astronomers, it was like finding a message in a bottle, bobbing on the cosmic ocean, carrying secrets from a faraway shore. But the mysteries didn't end there. As observations poured in from telescopes around the world, Oumuamua continued to confound expectations. It was tiny, perhaps only a few hundred meters long, but it reflected sunlight in a way that suggested an odd, elongated shape. Some imagined a cigar, others a flat, spinning disk. It tumbled through space chaotically, as if caught in a slow, weightless cartwheel. And most strangely of all, it wasn't slowing down the way it should. Under the sun's pull, natural objects lose speed as they climb away from the inner solar system. But Oumuamua was doing the opposite. It was accelerating. Just a little, a barely measurable nudge, but enough to set off alarm bells in the minds of scientists around the world. Something unknown, was pushing it along. And in that moment, Oumuamua transformed from a curiosity into a mystery that would divide scientists, ignite imaginations, and spark one of the greatest debates modern astronomy has ever seen. The impossible acceleration. At first, it seemed like a mistake. The numbers didn't add up. The trajectory was off. Some force was gently, but unmistakably, pushing Oumuamua faster and faster as it left the sun's embrace. It wasn't much. A subtle, delicate boost, just a few meters per second. Barely noticeable against the vastness of space. But in the precise language of orbital mechanics, even the smallest deviation meant something profound. Natural objects don't behave this way. Asteroids, comets, dust, all fall under the same rule. They come in, they curve around the sun, and they drift away, slowing as they go. Gravity pulls, motion obeys. But Oumuamua was breaking the rules. At first, astronomers reached for familiar explanations. Could it be a comet after all? Comets accelerate because, as they approach the sun, the heat causes ice to vaporize, creating jets of gas that act like tiny thrusters. But no jets were seen, no gas, no tail. Even the Spitzer Space Telescope, one of the most sensitive infrared instruments we have, spent 30 long hours staring at Oumuamua, searching for any hint of outgassing. It found nothing. It was as if the object was made of something different, something tougher, something stranger. Perhaps it was metallic, they wondered, or coated in a crust that sealed away any internal ice. Perhaps it was something else entirely. Theories began to swirl. Could it be a fragment of a shattered world? An exotic shard of frozen hydrogen? A sliver of cosmic debris ejected by unimaginable forces? Or, the thought whispered, daring to be spoken aloud, could it be artificial? Could it be something built, not born? Something sent, not scattered? In the great halls of academia, such ideas are usually met with skepticism, even scorn. But with Oumuamua, the rules were already broken. Nothing about it fit the neat categories we had spent centuries constructing. For the first time in a long time, scientists found themselves staring into a cosmic mirror and realizing they didn't have all the answers. In the cold emptiness of space, a tiny object was rewriting the laws we thought were carved in stone. And it was doing so silently, relentlessly, as it spun and sailed away into the night. The Battle of Theories. The mystery of Oumuamua hung in the air like a question no one dared answer. Across observatories, universities, and conference halls, a debate erupted, fierce, passionate, and unlike anything astronomy had seen in years. At the center of the storm stood two opposing visions: Harvard astrophysicist Avi Loeb stepped forward with a radical idea. What if Oumuamua wasn't natural at all? What if it was a probe, a piece of alien technology, abandoned or adrift? Loeb pointed to the acceleration. He argued that if Oumuamua were incredibly thin, thinner than a sheet of paper stretched over the length of a skyscraper, it could act as a light sail, pushed along by the faint pressure of sunlight itself. Nature, he insisted, doesn't build thousand-foot-long razor-thin structures, but intelligent beings might. His theory made headlines around the world. It captured the public's imagination. It dared to ask, what if we were not alone? And what if, just maybe, the universe had already left a calling card at our doorstep? But in the scientific community, many pushed back. Extraordinary claims, they reminded, require extraordinary evidence. Entered Daryl Seligman, a young researcher with a more grounded explanation. Along with Jennifer Bergner, he proposed a different idea, that Oumuamua wasn't a spacecraft, but a new kind of comet. A dark comet. Unlike traditional comets that blaze with visible jets of gas and dust, Oumuamua might have been shedding something invisible, pure hydrogen. In the frigid depths of interstellar space, ice bombarded by cosmic radiation could trap pockets of hydrogen gas within its structure. When warmed by the sun, that gas could be released, providing the subtle thrust needed, without any visible tail. It was an elegant theory. It required no aliens, no engineering marvels, no extraordinary assumptions, just nature in one of its quieter, stranger moods. But Loeb wasn't convinced. He challenged the dark comet idea, arguing that hydrogen icebergs would have evaporated long before reaching us. The battle of papers, lectures, and counter-lectures raged on. A cosmic courtroom where the only evidence was a fading trail across the stars. Neither side could prove their case. And all the while, Oumuamua itself drifted farther and farther away, carrying its secrets into the darkness. Perhaps it was a shard of ice, cracked and battered by millennia among the stars. Perhaps it was a relic of a lost civilization, a silent ambassador crossing gulfs we can barely imagine. A reminder that the universe is not obligated to make sense according to the limits of human imagination. Theories rose, theories fell, but the mystery remained. And the need to understand, to chase that fleeting visitor into the night, only grew stronger. The hunt for dark comets. If Oumuamua was a mystery, then perhaps it wasn't alone. Perhaps there were others, smaller, quieter, hidden in plain sight. The idea was simple, but revolutionary. What if our solar system was teeming with objects just like Oumuamua? What if we had been looking right at them, but failing to see? Inspired by the dark comet theory, astronomers turned their attention inward, toward objects already catalogued, already labeled, already familiar. Near-Earth asteroids, tiny wanderers buzzing close to our home planet. Most had been dismissed as ordinary rocks, inert, harmless relics of the solar system's construction. But what if some of them were hiding a secret? Researchers combed through the data, scanning for anomalies. They searched for anything that moved in ways it shouldn't, drifting, accelerating, deviating ever so slightly from the paths gravity alone would predict. And they found them. 6 objects, 6 tiny bodies that, just like Oumuamua, exhibited unexplained accelerations. No visible outgassing, no cometary tails, just the quiet, steady signature of motion without a cause. Most were no larger than a few meters across. insignificant specks against the grandeur of the planets and stars. But in their behavior, they held whispers of something profound. Maybe, Seligman and his colleagues proposed, these were dark comets too. Not frozen hydrogen necessarily, but ordinary water ice, battered by radiation, hiding tiny reservoirs of gas. And maybe, just maybe, dark comets weren't rare. Maybe they were common, abundant. Part of a hidden ecosystem of objects too faint, too subtle, too easily overlooked. It was a thrilling, humbling idea. That the solar system we thought we knew, the safe, charted realm of planets and asteroids, still held secrets. Still held ghosts moving among us, unseen. One of those 6 objects, a tiny asteroid named 1998 KY26, was already on the schedule for exploration. Japan's Hayabusa 2 spacecraft, after completing its primary mission, had been tasked with visiting KY26 in 2031. A tiny, fast-spinning world, only about 30 meters across, yet carrying with it the chance to glimpse the invisible forces that might have shaped Oumuamua's journey. If KY26 exhibited the same strange acceleration up close, if it showed signs of trapped gas escaping without dust, it would be a victory for the dark comet theory. A small, cold triumph in a universe still filled with wonder. But if not, then the mystery would deepen, and the ghost of Oumuamua would loom larger still, a messenger whose meaning remained tantalizingly out of reach. One way or another, the search was on. Not just for alien artifacts, not just for strange visitors from the stars, but for the hidden truths drifting silently among us. In the end, it wasn't just about finding out what Oumuamua was. It was about finding out what else we had missed. What other secrets the cosmos had quietly tucked into the darkness, waiting for us to open our eyes. Chasing a ghost. By the time we understood what Oumuamua was, or rather, what it wasn't, it was already slipping away. Across billions of kilometers, it tumbled silently, fading into the black. Most astronomers accepted it was too late, too small to track, too fast to catch. A mystery lost to the stars. But not everyone was ready to give up. In conference rooms and laboratories around the world, a new question began to burn. What if we tried? What if we refused to let this messenger vanish without a fight? Thus was born Project Lyra, an audacious plan to chase a ghost across the cosmos. The challenge was enormous. Oumuamua was already traveling at 26 kilometers per second, faster than any spacecraft humanity had ever launched. And with each passing day, the gap widened. It wasn't enough to catch up. We would have to do so at impossible speeds, and then slow down enough to study it. No rocket on Earth was ready for such a task. But in the minds of dreamers, solutions began to take shape. One idea was to launch a probe toward Jupiter, stealing a slingshot of speed from its massive gravity. Then, the probe would dive back toward the Sun, falling into a tight orbit, accelerating to breathtaking velocity. At the closest point, engines would fire, hurling it outward like a stone from a cosmic sling. With enough speed, perhaps 70 kilometers per second, it might just overtake Oumuamua, might just intercept it in the endless dark. But there were problems. The maneuver was complex, dangerous, never before attempted. The probe would need a heat shield strong enough to survive a near brush with the sun's fury. Every gram of mass, every bolt, Every wire had to be justified. And even then, there would be no guarantees. Another plan suggested a different path, using gravity assists from Earth and Venus, threading a complex dance through the inner solar system before catapulting outward. Slower, safer, but still a race against time. Either way, it would be a journey of decades. A probe launched in the 2030s might not reach Oumuamua until the late 2040s, chasing a fading echo across billions of kilometers. And when it arrived, it would find a speck, no larger than a skyscraper, tumbling unpredictably through interstellar space, a target barely visible even to the best eyes humanity could build. It would be like trying to catch a leaf in a hurricane, with a net woven from hope and mathematics. Still, the very act of planning such a mission spoke to something deep within us. A refusal to let the unknown slip away. A willingness to pursue mystery across any distance, at any cost. Because Oumuamua was more than an object. It was a reminder that the universe is still full of surprises, that not everything has been discovered, that sometimes the most important thing we can do is simply to try, to chase the ghost, even if we never catch it. The next visitors from beyond. For all the wonder Oumuamua brought, it also brought regret. We had found a messenger, but far too late. By the time we spotted it, it was already 33 million kilometers away, racing beyond our grasp. We had barely 40 days between discovery and disappearance. Hardly enough time to understand, much less to act. But next time, we will be ready. At the edge of a mountaintop in Chile, a new set of eyes is preparing to open. The Vera C. Rubin Observatory, one of the most ambitious sky surveys ever undertaken. Its powerful telescope will scan the heavens night after night, capturing the entire southern sky every few days with breathtaking sensitivity. It won't just watch the stars. It will watch everything, every speck, every flash, every shadow that moves. And among those countless images, it will find them. The wanderers, the strangers, the next interstellar visitors slipping into our solar system. Astronomers estimate that an interstellar object the size of Oumuamua passes through the inner solar system roughly once a year. We simply haven't had the tools to spot them. Until now. The Rubin Observatory will catch them months in advance, giving us time not just to observe, but to intercept, to study up close, maybe even to welcome. Meanwhile, other missions are preparing in parallel. The European Space Agency's Comet interceptor will launch in 2029. A spacecraft built not for a known target, but for a future surprise. It will wait patiently in orbit, poised like a cosmic trapdoor spider, ready to spring when a new visitor is detected. For the first time in human history, we will not merely react to the unknown. We will hunt it. The dream is no longer to stumble upon messengers from the stars by accident. It is to meet them on purpose, to greet them with open eyes and ready instruments, to shake hands, in a way, with the universe beyond our own. Of course, there are no guarantees. Perhaps we will wait years for the right object. Perhaps the visitors will remain shy, darting past at impossible distances. Or perhaps the sky will surprise us again. Perhaps the next Oumuamua is already on its way, hurtling toward us across the great emptiness, unseen but inevitable. This time, we will be watching. This time, we will be ready. And maybe, just maybe, we will finally be able to ask the questions that Oumuamua left unanswered. Face to face, under the vast, silent stars.